Welcome to AI for Good. This session is an introduction to cognitive services vision capabilities. I'm Alicia Moniz. I'm a technical architect for data and AI. I'm also an active member of PASS.org. I'm also an active member and organizer for the global AI community, and I enjoy empowering others to embrace AI in Azure. So thank you for having me here, and I'm excited to be speaking with you today. So today I'd like to talk to you about the capabilities enabled by Cognitive Services Vision APIs. As part of the AI for Earth program, Microsoft has done a really good job exposing capabilities for classification, object detection, and deep learning, and making these tools available for consumption by humanitarians worldwide. Classification and object detection are fundamental capabilities of AI with images. So we're going to step through the AI for Earth APIs to get an understanding of AI using computer vision. Finally, we're going to build our own image classifier. AI for Good is the umbrella that covers Microsoft's programs supporting sustainability and accessibility. Through programs like AI for Earth, Microsoft empowers humanitarians by providing the technology, resources, and expertise to solve humanitarian issues. Through this program, organizations have access to Azure infrastructure, including the AI for Earth API framework, the AI for Earth API platform, and the Geo AI Data Science VM. These tools jumpstart capabilities for engineers wanting to leverage Azure. AI for Earth grants are focused on problem solving that involves climate, agriculture, biodiversity, and water. Organizations can apply for Azure Compute grants of $5,000, $10,000, and $15,000, as well as special grants. So right now, the National Geographic Society and Microsoft's AI for Earth program has a request for proposal open. It's for the AI for Earth Innovation project. And the focus area is biodiversity or climate change. And the deadline is October 21st, 2020. So hopefully after this session, there'll be some interest, or maybe if you have an organization that you volunteer or work with and there's some interest there, but definitely here to increase awareness so that we can increase participation in the program. So the three AI for Earth APIs that we'll be talking about today all leverage AI capabilities for vision. So the species classification API leverages Vision API to predict and classify images of wildlife. The camera trap API leverages classification and object detection to identify and label multiple objects within an image. And the land cover API leverages deep learning to predict and classify land cover. As a side note, AI for Earth also offers additional resources to members. So there's additional data sets that are available for consumption, and these help to kickstart machine learning projects because, again, analysts don't have to curate or maintain or generate these data sets. These data sets are prepackaged and made available to data scientists and analysts for their easy consumption in Azure. And there's no fee to use the data sets, but you do have to pay pay for any of the storage or any of the ingestion services that you use to bring these data sets in and out of your project. So these are a few of the data sets that are related to weather and some of the AI for Earth initiatives, but there are actually quite a few open data sets out there. So I would recommend taking a quick look when you have a chance, because these are tools that will help you kickstart a machine learning project. So what is classification? So when we talk about image classification, what we're talking about is supervised learning. So we are going to take a set of images, and we are going to upload these images to storage, and we are going to label these images, and we're going to train the model off of this training set to say that this is what a cat looks like, and this is what a dog looks like. And the images are going to be cat, 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 dog, 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 dog. And we are going to provide enough true positives and enough true negatives that the machine learning model is capable of making these predictions with a fair degree of accuracy. So that's supervised learning. And what the cognitive services on Azure do is they actually sit on top of a data set, and this is a curated set of images that Microsoft curates and maintains. So as a programmer, I don't have to collect images of cats and dogs anymore. What I can do is I can go ahead and leverage Microsoft's Vision API, and now I'm just responsible for passing the image of the cat over or the image of the dog over and finding the results and parsing the results set back from the API. But I'm no longer responsible for collecting that data, curating that data, storing that data, and training the machine learning module. So the computer vision API is a service that will do all that for me. And as the machine learning model gets more intelligent and continues to learn, then I also benefit from that. So what I get back from that service is I'll go ahead and get back a label for my image, as well as a confidence score. So today we'll be looking at the species classification API, which leverages the computer vision service underneath. So when we talk about object detection is going to be fairly similar to classification, except classification will label an entire image. With object detection, we're actually labeling multiple objects within the image, and we're able to identify coordinates for the object within the image as well. So we'll go ahead and get multi-labels as well as bounding boxes. And the bounding boxes they'll form a rectangular shape. So we'll get 4 coordinates back from that. We'll get a left and a right for the top and the bottom of the image. And we'll go ahead and see that functionality when we go through the camera trap API. Now, what is deep learning? So deep learning is going to be a machine learning module that not only makes a prediction, but makes a prediction, takes user feedback, and then is capable of updating that prediction and updating the results of that prediction. So deep learning is more of a phased and recursive approach to machine learning and predictions. So we'll take a look at the land cover demo, and that will give us a little bit of an introduction to deep learning in images. And finally, what do we do when we're not able to get a prediction out of the computer vision API? So the computer vision API is, again, it's supervised learning. So there is a predetermined curated data set that's driving the modules. So the curated data set is stored and maintained and is abstracted behind the API functionality. So we do not have the ability to change any of that. So as we walk through these APIs, we'll see that the images can be labeled and validated, and this affects the confidence levels of our predictions. The Computer Vision Cognitive Service is a plug-and-play API that programmers can easily leverage within their applications, while the AI for Earth APIs are focused on images within the wildlife and nature domains. So what is the difference between computer vision and custom vision? As we walk through these AI for Earth APIs, our results are based on supervised learning. So that means batches of training images have been uploaded to Azure storage, the images have been labeled, and the results have been validated. This affects the confidence levels of our predictions. The Computer Vision Cognitive Service is a plug-and-play API, while the AI for Earth APIs are focused on images specifically within the wildlife and nature domain. So the Computer Vision Cognitive Service can additionally classify common objects in the scene, identify celebrities and landmarks, as well as perform OCR and handwriting recognition. So computer vision will allow us to pass the image or the URL to the machine learning module. It's already been built and trained. So the API has predefined parameters and set outputs, and we have no way of modifying or altering the models being utilized. So what happens when the question is, I don't want to just identify all the puppies in the picture. I want to identify my puppy in the picture. And that is when we would leverage custom vision and build our own classifier so that I have the ability to provide my own set of images to the data set and conduct my own level of training. So at the end of the session, we'll go ahead and give a try to building our own classifier, and we'll see how easy that is to do in cognitive services. So we've reviewed some AI vision concepts, and now it's demo time. So let's take a look at the AI for Earth API capabilities. So let's get started with the AI for Earth APIs. We can go ahead and jump on over to the AI for Earth technical resources page, and we'll see that there's pretty detailed information about each of the APIs here. So there's line cover mapping, there's species classification, and there's camera trap. And each API is going to have a link to the demo, a link to the notebook, and additional docs and code available. But you also want to note that there's a request here for an API key. So because these are APIs that are managed as a service by Microsoft, we don't have to build any of the compute. We don't have to do any of the code for the functionality. What we're doing is we are passing our image file over to a machine learning module that has already been built and is trained and maintained by Microsoft. So on the developer end, we request an API key, and then we're provided with access to this API interface. And right now I have the land cover mapping key, and I can go ahead and make predictions against it. So what I'd like to do is get started with the species classification API, and that is available via this web page where I can go ahead and interact with it and see the result set without having to spin up any resources or spin up any code. So the website is fairly easy to use, and I can go ahead and do a search for more images, and this is a search for humpback whales. So right now I'm simulating a post message to the API, and this is representative of what type of results I would get back. So there has been some training, some supervised training to identify not only whales, but different species of whales, and that's how detailed their training was. So not only is the model identifying the humpback whale with a certain degree of confidence, but it's also providing feedback as to other types of whales. And this tells us that there's very, very minimal confidence, but these animals are also part of the training set. So the APIs will usually return results back in a JSON format. So it's very, very easily parsed through the many different languages. So when you go to the API pages, you can usually interact with the APIs using C++ or Python or JavaScript. So this is standard functionality for classification. Next up is the camera trap. And the camera trap not only does classification, but it also does object detection, where it will count the number of instances of an object within an image. So we can go ahead and start scrolling through some of these images, and we can see the results down here. So we've got warthog, and I'm looking for an image with more than one animal. And so we notice that there's 2 giraffes in here, and I guess eland is a type of a giraffe. So we have a 61.83% chance of that being eland, and 37.71% likelihood of that being a wildebeest. And we've got two sets of bounding boxes here. So the bounding boxes are, you can see that they're rectangular and will receive back 4 points, which reflect the top, bottom, left, and right of the boxes. And that's standard functionality for object detections within the Vision APIs. So the last API is the land cover API. And this pulls in Azure data. And so what we're looking at is we're looking at geodata. And as we zoom in on different points of the map, there is going to be predictions made as far as what type of covering is over that part of the map. So we can go ahead and see that the 4 types that are assumed are water, forest, field, and built is going to be either buildings or highways or something that's man-made. So what's really neat about this is that there's a high degree of deep learning that's included in this functionality, because they have also made it interactive, where your inputs can change the outcome of the predictions. So if you have a boat pier that is surrounded by water, and the math kind of averages out so that that boat pier is colored blue when it should be colored brown because it's a man-made foundation, then you can go in with the software and you can go ahead and tag it as what it truly is. So as an example of that, I do have a body of water. So this is Braze Bayou, and I am going to input the coordinates here to get closer to it on the map. And I'm based in Houston, so this is a waterway that is near me that generally tends to flood when it rains. So this is a body of water that is studied and researched by many people in my area. So I can go ahead and start off with a general patch. So I'll just do the default size patch there. And then I'll go ahead and zoom out. And you'll notice that there's really no blue anywhere here. And even though it's a body of water, the water is green. So at this point, the model isn't thinking that there's water in there. So what I can go ahead and do is I can go ahead and increase the weight of the water, and I can decrease the patch size so it's way more detailed. And we'll just flip on over to this view so that we can see the waterway a little bit better as we're working with it. And I can go in and I can start tagging parts of this image as water, and then the math will average out to areas that are near there, and we'll start updating correctly some of these water elements that are within the image. So this is an example of deep learning where the data elements have been uploaded. So the image has been uploaded, the water elements have been flagged, the forest elements have been flagged, and the field elements have been flagged. And now the model is taking user input to update the predictions and alter what is returned back to the user. So it's pretty neat that they've covered so much of the functionality of the computer vision for these geologists. And so if you're going to get started with the computer vision service, then AI for Earth is definitely a good place to start, because a lot of the functionality has been exposed and is ready to use in these services. So I recommend you jump on in there and start playing around, because it's pretty interesting, the use cases that you can think of. And a lot of what I've seen is predictive maintenance in addition to the climate change. So, are there ways for us to identify and alert on activities a lot sooner with cognitive services and custom vision versus the amount of time that it would normally take to process data? So if we look at this waterway, because it's heavily monitored, has cameras at different points throughout. And when you look at this existing infrastructure and you think about, is there an opportunity for us to leverage that video and send it over to a service and maybe just do some binary tests, So is there a level that we can determine the flooding level, and can we do math as far as the rate at which the waterway is filling up? So if the waterway fills past 0.1 and then reaches 0.2 within a defined period of time, like 20 or 30 minutes, or whatever rate of change is, beyond our comfort threshold, then is there a way for us to visually trigger on that and alert and respond to that sooner versus processing all this data from maybe like IoT sensors, right? So these are some of the things that we have the capabilities of doing with computer vision that hopefully will really enable us to respond to events that much quicker. And that's really, I feel, what AI is about kind of making that link between decisions and actions just a little bit shorter. And I think we have a lot of opportunities there. So let's go ahead and create our own classifier. And today, what I'd like to do is I received permission from my daughter, and she said that she's all right with me using pictures of her puppy. So I have pictures of her puppy and I have pictures of her little stuffy dolls So what I'm going to do is we'll go ahead and walk through creating a classifier to go ahead and identify the puppy versus the dolls. And we can go ahead and navigate to customvision.ai and log in with our Azure credentials, and we'll go ahead and create a new project. I'm going to go ahead and call this Puppy Finder. And I've already configured a cognitive services resource in Azure. So this is where my metering will be received in Azure, which affects my pricing. So today I'm just going to do a classification. So I'm just labeling the image as a whole. I'm not trying to identify how many of an item is in the image. So that would be object detection. We'll go ahead and do a single tag per image. And the domains are we had talked about that curated data set. The domains are those curated data sets. So you'll notice food, landmarks, and retail. So if you are dealing with a subject matter that is related to one of those domains, then your accuracy will be higher if you use those domains versus the general domain. The puppy doesn't count as food or a landmark, so I'm going to go ahead and stick with general for now. So we can immediately jump in and add in our images. So I'm going to go ahead and I can do a Control A and add in all of my images, and the puppy's name is Brownie, so I'm going to go ahead and tag him as Brownie. And generally what I do when I'm building the models is I'll go ahead and put together the required minimum of 20 images. And then I also will keep a couple of images on the side for testing. And what you want to do is make sure that your testing image is not included in your training data set, because what you'll do is you'll get a false positive because the image will be exactly the same as what you're training with. So that is a unrealistic result of your image processing. So we're going to go ahead and let that upload. And another thing to keep in mind when you are working with images is that privacy and ownership of images is also a big concern when working with images and working with organizations and their employee data. So if you're building something for work, you might want to make sure that the privacy constraints over your data sets is being satisfied. And I do see that being more and more important as we're designing these systems. So I'm going to go ahead and label these stuffies, which is what my daughter calls these. And we'll go ahead and upload these images. And as you can see, 20 images is not a lot of images. So when you're building these models, you have to keep in mind that the results of your models are going to be affected by the variety and the types of images that you're uploading. So if you're in the lab and you're generating this model, and say you have a manufacturing use case or a farm use case, and you're looking at machinery, and the images that you're uploading is of brand new machines. You're taking images from the dealer website. The paint's all shiny. And then you go ahead and deploy your machine learning module, and images coming back from the field are of these machines covered with dirt. They're a little older, so maybe the paint's chipped here and there, or the paint's faded, so it's not that bright color anymore. It's like a duller version of the color. All of these things affect the accuracy of your data model. So when you're building these models, you really should be using images and use cases that are as similar to the real world scenario as possible, so that you can increase your likelihood of getting more accurate results. So the position at which the image is taken, the lighting, the angle, these are all things that that give enough of a variety of data points that the model can intelligently make predictions. So we have two sets of images. We have 20 of the brownies, 21 of the stuffies. We're going to go ahead and perform a quick train. And this is supervised learning. So we're sending 20 images of the puppy and 21 images of the dolls. And okay, so our model has completed training, and now I can go ahead and do a quick test. So I can go ahead and jump in here. I can browse to my test folder and pull out my test image and pass that over to the API. And there's a 100% probability that this image contains brownie. And so I hope you've seen that with a fairly small data set. So we only uploaded 20 images of the puppy, and we were able to get a pretty good validator as far as yes or no, is this the puppy or is this not the puppy? So you can see that as far as for experimentation and for these initial discovery and analysis, the cognitive services tool is very, very easy to use. There wasn't any machine learning or scripting that I had to do to build the model and train the model. And you can see how easy it is to interact with the software and possibly get other people up to speed on the software. So the custom vision API kind of truly makes machine learning a capability that we can all learn, and we can definitely teach the business, and we can have even developers and programmers and non-data scientists, non-standard data scientists. So this is a capability that we can very easily share with others on our team, and is very portable to different team members. So I hope that you've So our machine learning module has finished training, and what we can do now is we can do a quick test. So I can go ahead and click on quick tests. I can browse to my testing folder, select my test image and upload, and my prediction is that this is an image that contains the puppy brownie. So I hope that you've seen that with a very small set of images. So we've had 20 images that we uploaded of him. We can create a pretty accurate classifier to get that yes or no as far as is the object in the image, or no, is the object not in the image. And you can see that there was no scripting involved. There was no programming involved. So this is a very user-friendly and lightweight tool for people of many skill sets to perform machine learning against images. So I hope you'll take some time and give it a try and with your set of images. Thank you for spending the time with me today, and I hope that you've seen something new and that you're as excited as I am about the capabilities of computer vision and custom vision in Azure. So thank you, and I'm looking forward to answering any questions that you might have.